equal to PQ and AC is equal to PR. This shows that the corresponding three sides are equal in measure, and hence it is proved that triangle ABC is congruent to triangle PQR. In the same way, you can prove many more results. This is your theorem number 6.7. It says if a perpendicular is drawn from the vertex of a right angle of a right triangle. So first of all, let us draw. Suppose this is your right triangle ABC, right, in which you have angle B to be a right angle. If I draw a perpendicular from B, that is, let BM be perpendicular to the hypotenuse AC. So if a perpendicular is drawn from the vertex of right angle of a right triangle to the hypotenuse, then the triangles on both the sides of perpendicular, so these two triangles, first triangle is triangle AMB and second one is BMC, are perpendicular to whole triangle as well as to each other. That means we can write triangle AMB is similar to triangle ABC, triangle BMC is similar to triangle ABC, and triangle AMB is similar to triangle BMC. So the question arises how I can write the proper correspondence. So you can be knowing that if I see the first pair, triangle AMB and ABC, so angle A will be common for both, right? And as angle M is a right angle, here angle B is a right angle. So A corresponds to A, M corresponds to B. So obviously this B corresponds to C. So we have the first pair. I'll show you. First you need to draw an L shape, so you will never make a mistake. So this is ABC in L shape. Then you will be drawing this kind of shape arrow, that is AMB, right? And the third one is BMC. So from this arrow, this point will come outside here. This shape will be made. So BMC. Now let me give you the proof here. BMC and ABC, you can see angle C will be common. Same way angle M is equal to angle B because both are right angle. And then lastly, as both these triangles are similar to the same triangle, so they themselves are similar to each other. So even if I change the name of the triangle, let me take now PRQ, not the normal PQR triangle. This is PRQ, angle R is right angle. Let RT be the perpendicular. Now which three names you will say? Yes, first is L shape. So it will be triangle PRQ, right? Next is PTR. And the third one is RTQ. So if you learn this kind of shape, you will never make mistake in the correspondence, okay? So these three triangles are similar to one another. Now let us come to Pythagoras theorem, right? This is theorem number 6.8. Actually, this theorem was earlier given by ancient Indian mathematician Bodhian about 800 BC. And this is the reason sometimes this theorem is also called to be Bodhian theorem. Right? Now what is the meaning of this theorem? What this theorem states? It states that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. That means if I draw a right angle triangle ABC, here angle B is a right angle. So AC will be considered to be the hypotenuse as angle B is right angle. So hypotenuse, the square of the hypotenuse means AC square, is equal to the sum of the square of other two sides. Sum means addition. Square of other two sides means AB square plus BC square. So this we need to prove for the given figure. So let us see how we will prove. So the first thing is we will construct a perpendicular from B. Let us take BD is perpendicular to the base AC such that you may get A dash D dash C. That means D lies between A and C, right? So we will be writing now. So I have written for right angle triangle ABC where angle B is 90 degree. Let us assume BD is perpendicular to AC. As we have learned in the previous theorem, theorem number 6.7, whenever we draw a perpendicular from right angle that vertex in a right angle triangle, so these two triangles will be similar to the main triangle, right? So here I can say by theorem number 6.7, triangle ADB is similar to triangle ABC. And exactly in the same way, I can again write by theorem number 6.7, triangle BDC is also similar to triangle ABC, right? So these two triangles are similar to the main triangle. Now, as sides are in proportion, so we can say that by the definition of similarity, AD by AB is equal to AB by AC. You can write the ratio of two sides. I have written 2, you can take 3 also. Now, if you cross multiply, you will get AB into AB is AB square is equal to AD into AC, which is result number 1, right? Exactly in the same way for this you can write CD. I have taken last 2, right? So here also upon BC will be equal to BC upon AC. Again by cross multiplication you will get BC into BC will be BC square is equal to CD into AC. So this is result number 2. Now you can add result number 1 and 2. So let us see what we are getting. On adding result number 1 and 2, on the left hand side I'll get AB square plus BC square. On the right hand side it is AD into AC plus CD into AC. Now you can take this AC common. So this will be AD plus CD into AC. Now as we know in the figure, what is AD plus CD? It is equal to AC. So I can write afterwards, it is AC into AC, which is AC square. And you can mention the reason because D lies between A and C. And thus we have proved AB square plus BC square is equal to AC square. And this was our statement that the square of the hypotenuse is equal to the sum of the square of the remaining two sides. Now let us learn converse of Pythagoras theorem, that is theorem 6.9. It states that in a triangle if the square of one side is equal to the sum of the square of other two sides, then the angle opposite to the first side is a right angle. So previously we had done if it is a right angle, then the square of hypotenuse, and it is not given here, it is a hypotenuse. When it will be called to be hypotenuse? When we prove that that angle opposite to it is right angle. So we need to prove that the angle opposite to that first side is a right angle. So let us take for triangle ABC, if we have the square of one side, that is AC square, is equal to AB square plus BC square. So the square of first side is equal to the sum of the square of other two sides. So this is the first side. So angle opposite to AC will be angle B. So we need to prove that angle B is a right angle. That means the measure of angle B is 90 degree. So for that we will construct two triangles. So first of all I am drawing a normal triangle. It's not a right angle triangle. So I am not showing B as a right angle. We will later on prove that it is a right angle, right? And same way I am taking one right angle triangle PQR, right? So let triangle PQR be a right angled triangle having angle Q to be 90 degree. That means in this triangle angle Q is a right angle, right? Okay, if Q is a right angle, okay, so it is quite understood that PR will be hypotenuse. Okay, we have taken this triangle such that PQ should be equal to AB, this is our first condition, and QR should be equal to BC. We have taken such kind of triangle having PQ is equal to AB and QR is equal to BC, right? But I have not said that PR is equal to AC. If we are able to prove that the third side is also equal, so we will be able to prove the given result. Now, as triangle PQR is a right angle triangle, so by theorem number 6.8, that means by Pythagoras theorem, I can say Q was a right angle, right? So PR will be the hypotenuse. So I can say PR square is equal to PQ square plus QR square. But what we had supposed, what is PQ? In place of PQ square, I can write AB square because of our supposition. Same way, what is QR? So QR is equal to BC. So QR square will be replaced by BC square. But what was given in the data, it is given AC square is AB square plus BC square. So here I have got AB square plus BC square, which can be replaced by AC square. So I got PR square is equal to AC square. This means I got PR is equal to AC. So now we have got all three sides equal. PQ is equal to AB, QR is equal to BC and PR is equal to AC, right? It is proved. And therefore, triangle ABC is congruent to triangle PQR by SSS congruence result, right? And if two triangles are congruent, so we can say the corresponding angles also will be equal. So angle B is equal to angle Q. But what was our angle Q? Q was 90 degree, and hence it is proved that angle B is also 90. Thus it is proved that angle B is a right angle, right? And hence the result is proved.